Hello everyone and welcome back to the third part of my LUA tutorial series. Today we will talk about functions, because if you put on a new fresh LUA box, there's already this function in here. And when I went into LUA, always wondered why this is there, what it does, and no one was able to explain it to me properly. So here we are today, where I teach you why this is necessary and what it does. I already pre-shadowed a little bit in the previous series, previous parts of this tutorial. I mean, why the eye is necessary. The eye is an object. This is the name from informatics for this type. It is not a variable, so it is an object, and the object is something more complex. I didn't get yet completely. But object basically contains a lot of information, and the game stuffs all the information it can provide into this object each game tick. And this is just what it does. So the eye is like a big book full of information, and it gets rewritten every game tick. And you can now choose any page. This is basically different pages in this book, and check what is written in there and access this information. So this is why the eye is there. The update is there because a function called update will just be called, I think you name it called, will be activated 40 times per second. This is the speed the games should run on. If you press F4, you get this FPS information. Right now this game is running on 80 FPS. This is the graphical operation. And the actual physics only runs at 40 iterations per second, which means that positions of blocks or bullets will only be calculated 40 times per second. And I have double the time FPS, which means that the bullet actually is presented at position where it actually never is calculated. But that's stuff which hasn't much to do with our subject today. So just keep in mind that this update function is called 40 times per second. So if you want to update stuff currently, or you want to initiate your code, you basically have to write it in there, because otherwise it will never be will never be activated or never be used. So this is why we use this. And now I will explain functions in general. Let's just do something very simple. I will you use functions to outsource operations. So you basically use them to organize your code, and if you have to do something multiple times, you want to use a function for that, and I will show you why. If I'm really stupid, because what I'm doing now doesn't serve any purpose, it's just an example, but if I want to calculate 3 plus 4, and I want to outsource the plus, I do as followed. I define a function, and let's call this function plus. So we write function and end. This is determined by how the code works. Okay, you always need that, and then you can put a name. I will call this function plus function. You can also just name it plus or whatever. Let's name it plus. You will need those two brackets. And you now write into those brackets what this function uses as an input. And we will just call the input A and B. And you separate them by a comma. This is already a functional function. The only thing we'll need now is a return value. So the function now has an input, and we want to define the output. And the output will just be C. So we want to return C. And what we do now, we just say C equals A plus B. And we are done. So this function takes A and B as an input, then it has an operation with those two values, and then it returns the result of this operation. And now we can do as followed. We can use this function we just created. This function works like any other function, where you can, for example, input an altitude or whatever. You can just write the name of the function, plus, we'll need the two brackets. We will need a semicolon at the end, of course, and we give the function input values. And the input values are A and B, so we just put in there 4 and 7, for example. And now we can just say result, for example, equals the plus function of 4 and 7. And then we can print the result. And this should now say 11. And there we go. So, what's happening here? We have two functions. This function isn't called by the game by default, only this function. So this is called 40 times per second. And yeah, it will just recognize, oh, I want to define a variable and save data in it. Then it checks for what data should be saved. Ah, okay. The result of the plus function should be saved, and the plus function has 4 and 7 as an input. So the LUA box checks for a function called plus. So it searches for function, finds the function defined right here, checks if the name is correct, and yes, the name is correct, so it proceeds. It checks if all inputs are given, and yeah, for A there is the 4, and for B there is a 7. So it also checks, okay, I have everything to initialize the function. So then it goes to the next line, recognize, oh, a new variable named C, and C should be the sum of A and B. So it does that, already calculates 11 right here, and then it returns the 11. And the return value will be then saved in result, and result will then be printed. By the way, this function of course has to wait in this line until this function is completely done. So this is also the order in which stuff is executed. What I can do now, I could also try to print the result already right here, correct? I actually don't have to return anything. I could just call the function. Doesn't have to return something. You can also just run it. And if I try this, let me clear the log. Apply changes, clear log. Didn't save this correctly, so let me replace that. It won't work. And maybe you can tell why it won't work. But then you're really smart, because we're just learning that. I told you that the I in here provides all the information that is in I to this function. And this function up here doesn't have the I. So it tries to access the information the game provides over I, but it fails because it doesn't have I as an input. But if I just do that, now this will work. And of course it doesn't. So let me try to do this magic trick again. Interesting. So what have I done wrong? Let's check. Attempt to index I. Of course. Let me explain you. It will start by executing this function 40 times a second. So it initializes, it calls this function, and then it wants to execute the plus function, and it only has 4 and 7 as an input. So yeah, this is where it fails, because I give it the 4 for A and the 7 for B, and then the I, and here's just emptiness. So I have to put the I here as well. This also means that I could name this up here different. So let's name it all the info, and then I could also write all the info here. All the info. And now it works. Of course, it tries to print the result, which is also wrong. It should try to print C. So there we go. So let me explain the final time. This function is executed because it is executed 40 times per second because it's called update. And then it tries to execute the plus function. We have defined the plus function right here. This is the name. And it tries to feed the 4, the 7, and the I into this function. It tries to give the information over. And this is a success because this function up here wants 3 values, A, B, and all the information. And yeah, so the 4 is moved into the A, the 7 is moved into the B, and the I is moved into all the information, or all the info. And this is what this function has to work with. And it adds A and B together and extracts the log function out of all the information. Well, we could also just name that I, because this might be a little bit, too complex. Let us just name I, still works. And to give this function actually a purpose, let's make this a little bit more complex. We could do something like this: a to the square plus a to the fourth power divided by b plus b, something like this. A very, very ugly function, and you don't want to see this reappearing in your code, so you use a function to compress this complex operation into this one line. This is why you use functions, to compress stuff. So in your final master function, the update function, you later on only have functions which look like this, and so you just have a lot of functions and not much operations because you outsourced all the stuff. Makes your code way more organized, and now you should really and fully understand also in depth why there is a function right here. Somewhere in the code of the game, somewhere in the files, there's a line which says call function update, and the game will go through all Lua boxes which are currently present in the world, and it will try to run the update function in all Lua boxes. Basically what I did here, but in a global scale, right? This is what happens. Okay, I hope you learned something. I will mark this Lua box as not important. Not important will be yellow, I don't know, maybe white. Not important will be white. And by the way, from the spaces you can count what tutorial this Lua box is in, right? This is why I'm doing that. So, see you in the first tutorial, in the first part of this series. Thanks for watching until the end. Leave a like and a comment if you like what I do, and if you have any questions, of course you can ask me. You can also find me on the Discord. I should have put my name into all video descriptions, but if you're smart, you have read the video description anyway. So see you in the next part. Bye.